Good morning. We are going to discuss a topic on MapReduce. This topic is a part of the Big Data syllabus in the MCA course. My name is Miganka Sarma. I am an assistant professor in the Department of Computer Science, University of Science and Technology, Meghalaya. The particular topic on MapReduce is important in the current context of the rising demand in the subject of data analytics, particularly in the subject of big data. To begin with, let us compare a classical data processing versus the big data that we tend to consider as a big in terms of what parameters. So classical data processing is a technique of traditional programming computation where the program initially resides in the disk, particularly the secondary disk, and then the program transfers to primary memory, then over is processed in the CPU. This particular technique is called the classical data processing, where the data fits into the memory. We should observe here that the initial data is small enough to fit into memory and small enough to fit and accompany within the disk. Here memory refers to the primary memory, which in most cases is in the order of 4 to 8 GB. Our data that is used in traditional programs are well within the capacity to be accommodated within the limit of 8 GB of memory. So we do not consider a 8 GB of data to be a huge computationally challenging task in terms of classical data processing. However, if the amount of data increases to 80 or more, for example, then the processing speed not only would affect but also the available memory within the system that can accommodate the all 80 GB of data is a challenging task. As we are aware that the current programming infrastructure is not able to accommodate 80 GB of primary memory data records simultaneously in the same time. The classical data processing techniques does not suffice the problems of big data. Here let us take another motivation for the requirement to study the big data, particularly the MapReduce programming model. For example, here we can see, suppose there are 10 billion web pages with average size of 20 kilobytes. So in here 20 KB means there is a maximum 5 to 6 pages within every website, and suppose 10 billion web pages are there within the global web space. So in such case the total web space memory encompasses 200 terabyte, and assume let us have a disk read bandwidth of 50 megabyte per second, 50 MB per second. Then the total time to read the all 200 terabyte of the web pages in order to process meaningful information will be accommodated to 46 plus days. So just in order to read the entire 200 terabytes of web data, there is a time requirement of 46 days and higher, which is next to impossible in terms of human time utilization. Thus, reading only if takes more than 46 days of such a huge data, the time required to process and analyze and find out meaningful information within such a huge data is surely another mountain to climb. Now, what's the solution to such big data? The solution to such huge amount of data lies in the technique of data splitting, where we split the original data into small chunks. Such small chunks of data are fed into the computers, and the initial chunks are then transferred to a central server which collects the data. Now let us discuss some of the other techniques that are required in order to understand this MapReduce programming model. The other techniques that required to study are MapReduce, Hive, Peak, MapReduce task, reduce task, and MapReduce execution composing the MapReduce calculation algorithms, the data processing layer in the application support layer. While the application layer in the data consumption of the big data architecture when using HDFS, the big data processing layer includes APIs of program, MapReduce, and Spark. The application support layer includes HBase that creates column family to store using formats such as the key value pairs in the JSON file. The key value pairs that discussed here can be understood from this example. The application support layer includes HBase that creates the column family data store using formats like the key value pairs. HBase, that is an integral part of the big data processing, stores and processes the columnar data after translating into MapReduce task to run in HDFS. So the HDFS is the Hadoop data file system. Support layer also includes Hive that creates SQL-like tables. Hive stores and processes table after translating into MapReduce task to run in HDFS. Hive creates SQL-like tables in Hive shell. Hive uses HiveQL processes, queries, and unstructured queries, aggregation functions, and summarizing functions, such as functions to compute maximum, minimum, average of selected or group datasets. HiveQL is a restricted form of structured query language. So what the Hive does is forms value pairs within the key identified from such large chunks of data. We here have A1 to B3 have distributed as 3 chunks of data within 3 chunk servers. The first server has A1, A2, B3, B1, B1, A1, B2, A2, A3, B2. Chunk servers also serve as compute nodes. These chunk servers contain the parts of the initially big data. That chunk servers also help in maintaining replication of the data. The data replication has certain advantages where the loss of data can be minimized. The smallest unit of data that can be stored or retrieved from the disk in the blob is deals with the deals in the HDFS is called a blob. Hadoop application responsible for distributing data blobs across multiple nodes to accommodate the MapReduce task. In order to process the data is efficiently distributed across multiple chunk servers by a Hadoop application. This requirement arises because mapping of stored value is very important. The number of mapped tasks in an application is handled by number of blocks of input files. Reduced task uses those values for further processing such as counting, sorting or aggregating. Application subtasks assigned for processing needs only the output of reduced task. Map-reduced programming model refers to a programming paradigm for processing big data sets with a parallel or distributed environment using map and reduced tasks. YARN refers to provisioning of running and scheduling parallel programs for map and reduced tasks and allocating parallel processing resources for computing subtasks running in parallel at the Hadoop for a user application. The HDFS and the GFS, the Google file system that is seen here, copies multiple versions of the same data. That also increases the redundancy within the dataset, but that is efficiently handled by the Hadoop system so that an effective mapping can be processed. YARN, that is a part of the MapReduce model, refers to provisioning of, running and scheduling the such parallel program for map and reduce tasks. The YARN is a resource manager that enables large-scale data analytics using multiple machines in the HDFS cluster. The HDFS programming model that runs the MapReduce model requires a script like Perl. A script refers to a small program for a few thousand lines of code in a language used for purposes such as query processing, text processing, or refers to a small code written in a dynamic high-level general purpose language such as Python or Perl. SQL-like scripting language means a language for writing script and processes queries similar to SQL. SQL lets us structured queries for processing in DBMS. An SQL requirement is much important in the task of counting words, where the count argument of the SQL return the number of values within the attribute of the similar nature. SQL-like scripting language means a language for writing script and processes queries similar to SQL. SQL lets us write structured queries for processing in DBMS, create and modify schema and control data access, create client for sending query scripts, and create and manage server databases. Query and change is also possible within the SQL setup as and when required. For an example that is discussed here, the problem of counting word. In the problem of counting word, we have a huge text that counts the number of times each distinct word appears in the file. A sample application is the analyze web server logs to find popular URLs. How to solve this with a single machine? In the case 1, the file may be too large, but the file may be too large and not be accommodated within the memory, but the word count pairs fit in the memory. We can create a big string array, or we can create a hash table. The word count pairs do not fit in memory but fit into disk. A possible approach for this is to use the getWords function along with the sort function, and the output is piped into the count function. The diagram here refers to a pipeline of 3 functions where the getWords function extracts the sentence and the initial words, which is piped into the sort function that is piped to the count function. The process is similar to what in the SQL consistency availability restrictions force us to understand. NoSQL relies upon another model such as the base model. This model has three principles: the basic availability, soft state data consistency in the developer's problem, and should not be handled within the databases if the SQL query does not support the consistency and availability. As this is a multiple node factor, when running such programs, mostly the distributed computing paradigm is used. Therefore, the pipeline is not static to the local system, but the pipeline may extend to a distributed cluster of systems where to efficiently manage the SQL, their consistency and availability may not be always true. As such, another form of query language that is being produced to handle such complex tasks is the NoSQL. NoSQL relies upon another model known as the base model. This model has three principles: basic availability, the availability of data even in the presence of multiple failures; soft state, data consistency, the developer's problem and should not be handled by the database. So that's what requirement of a NoSQL system is for the big data model, where the basic availability of the data must be possible even in the failure of the remote nodes, and in the soft state the data consistency is the developer's problem, should not be handled by the database. Eventual consistency when no new changes occur on existing data, eventually all accesses to that data will return the last updated value. The data architecture patterns that we see here, the data architecture pattern refers to formats used in the NoSQL DBs. Examples are the key value data stores, object data stores, column family big data stores, tabular data stores and document stores. Key value data store refers to the simplest way to implement a schema-less database, a string called key maps to value a large data string or blob, the basic large object. So here the basic large object is the data file that is accessed in the getWords function, and that is mapped to extract some words and count. This getWords function is piped to the sort function that is stored in the object data store. So the object data store refers to a repository that stores objects such as files, images, documents, folders, business reports, etc. System metadata, which provides information such as file name, creation date, last modified, language use, access permissions, supported query languages, and custom metadata, which provides information such as subject, category, and sharing permission. Tabular data store refers to table, column family, or big table like data store. Column family big data store refers to storage in a logical group of column families. Storage may be similar to columns or sparse matrix. They use a pair of row and column keys to access the column fields. Document store means a NoSQL DB which stores hierarchical information in a single unit called document. The particular document that we access here in the MapReduce model, where the data file extracts the keyword, initially the file will be stored in a document store. The big data table stores the column family in a data store. The column family store information as in a key value pair, which we observe here from the F1 file up to Fn file. F1 to Fn are set of files with set of words, and their key values are extracted in a tabular form represented by the index key1, k1 up to v1, k1 up to vn. In this particular case, we have 4 keys and 4 values for the individual keys. These tuple means the ordered list. The tuple means the ordered list of values, elements and values, and n tuple relates to a set theory or collection of sequences of n elements. Such collection of keys and values means a well-defined collection of distinct objects in a set. Objects of a set are the elements. A collection may be analogous to table of RDBMS. The RDBMS table also can be analogous to store the key and value pairs that is extracted from the F1 and F1 C1, F2 C2, F3 C3 map file. Collection database also refers to storage of a number of documents. The key value pairs that is observed here also performs a aggregate function. Aggregate refers to collection of data sets in the key value column family or big table data store which usually require sequential processing. Aggregation function refers to a function to find counts, sum, maximum, minimum, order statistical or mathematical function using a collection of data sets such as column or column family. Sequence refers to an enumerated collection of objects, the repetitions, which contain members similar to a set. Sequence length equals the number of elements. Sequence reflects an order which matters unlike a set. Document refers to a container for the number of collections. Container can be unit of storing data in a database such as the MongoDB database that can be aligned with the practical situations where a distributed model is required to implement the MapReduce step. In the figure here, what we see is the reduce phase of the MapReduce task. The big data processing employs MapReduce programming model. This particular model means a MapReduce program that consists of several smaller units called MapReduce tasks. A software execution framework in the MapReduce programming defines the parallel task. The parallel task can be seen here as the Hadoop MapReduce framework is implemented using the inner join. Many real-world situations are expressible using this model. The inner join is a default natural join. It refers to two tables that join based on common columns mentioned using the on clause. Such inner join can be used in order to join different keys and values aggregated from different distributed clusters. Inner join is the default natural join. It refers to two tables that join based on common columns mentioned using the on clause. Inner join returns all rows from both tables if the columns match. Node refers to a place for storing data, data block or read or write computations. Data center in a DB refers to a collection of related nodes. Many nodes form a data center or rack. Cluster refers to a collection of many nodes. Key space means a namespace or namespace to group multiple column families, especially one per partition. Indexing to a field means providing reference to a field in a document of collection that support the queries and operations using that index. A DB creates an index on the ID field of every collection. The MapReduce task that is shown here extracts the key value from a sentence that can be seen here. And the task of the job tracker and the task tracker MapReduce model consists of a single master job tracker and one slave task tracker per cluster node. The master is responsible for scheduling the component task in a job onto the slaves, monitoring them and re-executing the failed task. The slaves execute the task as directed by the master. The data for a MapReduce task is initially an input file. The input file typically reside in the HDFS. Files may be line-based log files, binary format files, multi-line input records, or something else entirely different. MapReduce framework operates entirely on key-value pairs, and such key-value pairs are a process of the output task, and the different types of the key-value pairs are processed by the HDFS. The map task means a task that implements a map that runs user application codes for each key-value pair. In such case, K1 viewer be the key, where K1 is the key, and key K1 maps to group of data values, and the values V1 are assumed to be last string refers to the input file. The output of a map would be 0, and when no values are found, or indeterminate key value pairs K2 V2. This indeterminate value V2 is the information for the transformation operation at the reduced task using aggregation or other reducing function. Reduced task refers to a task which takes the output V2 from the map as an input and combines those data pieces into smaller set of data using a combiner. The reduced task is always performed after the map task. Mapper performs a function on individual values in a dataset irrespective of the data size of the input. That means that the mapper works on a single dataset. The key value pair in the each phase, map phase and reduce phase of MapReduce has key value pairs as input and output. The data should be first converted into key value pairs before it is passed to the mapper, as the mapper only understands key value pairs of data. This mapper also has certain other subtasks that is described to be some input split function that defines a logical representation of data and presents a split data for processing at individual map function. The record reader communicates with the input split and converts the split into records which are in the form of key value pairs in a format suitable for reading by the mapper. When the map task completes, shuffle processes aggregates all the mapper outputs by grouping the key value pairs of the mapper count and the value V2 append in the list of values. The group by operation on intermediate keys creates the value V2. Shuffling and sorting phase collects and group together, creating a group in the each key. The partitioner also partitions the data. The partitions are the semi-mappers in the MapReduce. Partitioner is an optional class. A partition processes the output of map task before submitting it to the reducer task. Partitioner function executes on each machine that performs a map task. So this is all that discussed in these slides regarding the introduction to the MapReduce. So in a nutshell, the MapReduce model looks like a word extraction pipe to sorting and then pipe to counting the words that are stored as a key value pairs in order to process the MapReduce model. Thank you.